Yeah, okay. I'm Dr. Jun Zang, and I'm from University of Bath, and currently I'm the director of the research unit for water, environment, and infrastructure resilience. And also, I'm currently the chair of Primary. It's a network that is based in Southwest for research in marine renewable energy. So we all know is how can I change? Oh, that one. Okay, thank you. So we all know UK is a coastal country, so we have very long coastline. So that means much of the population live on or near the coast, and also much of the critical infrastructure and also are located along the coast as well. So it's like Ruth has highlighted, it's a risk from climate change and the sea level rise, and also its more frequent storm. What we have witnessed in the last 2 years, 2013, 2014 winter storm, and also 2015, that all highlight its risk and also the challenges, and particular for the coastal community and also for future resilience as well. But at the same time, we also have the opportunity for harnessing its marine renewable energy. And then we are leading in the offshore wind development, but certainly we can catch up with wave and the tidal energy development as well. So looking at what happened and then in the past particularly, and then after the Great Flood of 1953, just 60 years on, and we had 2013, 2014, it's winter storms, and then so it's just we have to ask ourselves, are our coast safe? What else we should do? So this year I had a very good undergraduate dissertation students. So we discussed why not? So we can do some comparison, particularly looking at the 1953 Great Flood and also 2013, 2014. So how we can assess the performance and then the British coastline, and then also exploring its future and challenges. So our study has revealed that British coasts are currently in a much safer state compared with 6 decades ago. And so, so what the evidence I can show you, so this has shown some the numbers and the figures. So we look at the number of deaths and from for both Great and the floods 1953 and also the December 2013 and the storm. So and also we look at the residential property flooded and also the area and the cultural land and internated and also the people evacuated. If you look at the numbers, so you can see is we really have the increased performance and from our defense, and certainly all these initiatives and also the efforts and the investment and is driven by the government is resulting we are in a much better position. But certainly, have we done enough? Okay. Certainly, Ruth has shown some the damages and then from the recent flooding event, and also in the 2013 and the winter storm, and we lost is a part of the city fence in Dr. Warren, and certainly the rail track has been suspended and stopped and the transport for almost 2 months' time. So you can see the loss, damage, and the disruption to the southwest economy is huge. So apart from Dr. Warren, on the other side of the UK coast, particularly on the east coast, and is coastal erosion, and particular is cliff erosion, is another type is coastal is the damaging of coastal erosion. Another problem is particularly if you look at the future climate change. So we are going to be in the worst scenario, most another extreme weather and the conditions will be coming. So that is about the challenges to coastal and the community. And on the other hand, the opportunities is we have, and from the easy access to the sea, and particularly we have been leading offshore wind in the last couple of years' time, but certainly is whole offshore is a renewable energy development, including and wave energy, tidal energy that represent is a huge potential and is great in the market, particularly for UK to maintain its leadership. And particularly we had talented people and then those working on oil gas industry, and in the past is 20-30 years time, and particular for the North Sea oil gas and exploration. But certainly we got those talented people, we got technology, we got infrastructure. Now we just need to have the the mission and the passion to have the investment, to have the support from the government to drive through and to accelerating the marine renewable energy development. So in the southwest, we are in a slightly good position. I know Wales, colleagues have done a great job in pushing in the tidal energy and wave energy development, and certainly in the southwest in the UK, we had expertise, we had facilities, and also we had capabilities. We got its world-class research universities, Plymouth University, Bristol, Bath, and Southampton, University of Exeter. So together with 2 units, so we create a primary partnership. So certainly we can work together. We can offer much more service and to help industry, to help the local region, and particularly in national, and also work with international network to get marine energy development a bit further, a bit accelerated. So we got research testing facility. We got Plymouth laboratory is fantastic facility there. We got Wave Hub, so that is similar to the EMAC. We got this demonstration drone, which can help commissioning and help in its commercial development as well. And we got its industry supply chain, which are available to help working together. So we are in a very, very good position. So in response to the need and to the recent development, certainly, and the marine energy that offer is a great opportunity for us to working together. So that's why we got a few universities and research units and the industry and set up and try to foster the research exchange and also collaborations and with wider committees with Welsh people, with Scotland, and with international community as well. So what our objectives certainly, and working together, and also driven is the research exchange. And each year we host a annual primary conference, and this is a free event. It's about 1.5 days, and followed by industry-driven workshop. And this year, the primary workshop and the conference will be held in Bath, particularly at the University of Bath. I'll be chairing the conference. So this is a free event, so that will be happening in early July. So certainly if you want to attend to join our conference, and this is certainly, and the registration and for coming to the conference probably will be open very soon. So send me email if you want to come. Okay, so that is about primary, and certainly this highlight is expertise and facilities and also capabilities we can offer. You can see we cover almost all aspects in its research and about marine renewable energies. Is from its material, and from its optimization, and from power taking off system, and also in the mooring, and also in its facility, and that could allow us and work together to provide one-stop service. And so that is the advantage we can have. So here, just highlighting our research currently being and working on. So numerical modeling work for wave energy and tidal energy, and also offshore wind, and also the laboratory in Plymouth, and also some kind of field test in Wave Hub, and also near Exeter, and for some the mooring and the facility as well. Okay, so that is about Southwest is marine renewable is a partnership, and then so in University of Bath, certainly we recognize the need for promoting this is a kind of wave energy, and particularly for the environment and the water and the water, and then is the energy shortage, and particularly the challenges due to the climate change. So we set up this is where research unit. That was 2 years ago. So we expanded very quickly, and at the beginning only myself, but certainly now we have 20 people, and with academics and peer students, postdocs working together. Certainly we welcome opportunities to work with wider communities like today's that network, and we are going to expand that network with industry as well. So we I'm going to highlight a couple, and the research we recently, have been doing in Bath. Certainly, we have, is the research about water quality, and also, flood, is a prediction, and then for urban flooding, for coastal flooding, and also for, is infrastructure and resilience, and we got different and kind of, is academics covering different area. And today our focus on a coastal and particularly in protection and also is marine energy development. So this is the research is led by my colleague, is Dr. Chris Blankenship. So he is leading international effort and to do some field monitoring about wave and its beach shoreline changes that could help to understand a bit more about coastal processes and how we can promote is this longer-term sustainable and beach and coastal, particularly for coastal protection. So this is the research led by me, and we try to understand, particularly doing field work and the laboratory experiment is very, very expensive. So we need to develop some excellent and accurate and particularly efficient numerical model to be able to do things very, very quickly, and probably within a few minutes or and a few hours we can at least to do some is very quick and the solution. So we look at the wave and the propagation transformation over submerged under breakwater, and to check how that is submerged under breakwater to help mitigating is the wave impact. What we found, if you see the wave from the left to right, and we start only a regular, very simple way, but once it's propagate over the top of the bar and also the lee side, you can see the waveform has been transformed considerably, so from very in a linear way and to the very strong nonlinear way, and also the wave height has been increased more than double. And another thing is, if we look at is the spectra, particularly the energy spectra, so single regular wave with single frequency, but once it's propagated over the breakwater, you can see how many more harmonics has been generated. So we have witnessed about up to 8 order harmonics. So that means wave energy really has changed. So we have to look at those and particular that impact and on the structure as well. So another test case we have been working on is collaboration with Plymouth University and other universities, particularly in the UK. We look at about breaking wave impact on vertical wall. Certainly, this is a very, very complicated problem, which you can see is bubbles and air resist is a very complicated free surface. So we have done both laboratory study and also is a numerical study. We try to understand what will be the high peak and the pressure and the loading onto the vertical seawall. So that could help for the future of the design of the infrastructure. So you can see that once we get the breaking wave impact on the seawall, we get really, really short and then a very massive peak under the pressure. So certainly for part of the structure, you have to design to be able to resist this violent, impulsive and the pressure. And also we have done some numerical modeling work that confirmed, and we can reproduce same kind of quality of the result just using our computer and sitting in our office. So another work we have been doing, and then that was a large scale experiment which has been performed in Denmark and funded by European funding. I was the project leader and leading a couple of universities from different countries. And what I have found from the breaking wave impact on this offshore wind turbine foundation is the loading we have been designing in the industry is not enough, because particular design code we normally use the linear wave theory. If the linear wave theory, and if you look at here, we have used the focus wave, which can allow us to decompose the total loading into different harmonics. So even we have the single harmonic, but certainly the high impulsive and the wave impact on the structure, which can generate much higher and the wave energy. So if you look at the second order, that is almost 60% of the linear wave loading, and the third order, so that means your linear wave loading is only about 30%. So I hope this message can be delivered to the industry people, how we can change design code to take account this is the higher order, particular and the resonance as well for the structure and the fatigue as well. So we also compare with other research from Imperial College as well. So that is all the numerical model and the experiment all confirmed in the results can produce is the same, consistent in its answer as well. So another thing we have looked at is about floating is the structure, and that is about is wave energy device. So this is a collaboration with Manchester, Oxford as well. So we try to look at how we can improve and the performance, and particularly optimize and the performance as well, and also look at is wave energy and devices in array, how we can enhance the performance. And the interesting is, if you put these devices in the array, and then so it's a particular, you can look at is only 2 meters and in spacing, and certainly is we are not losing out energy. Actually, we can maximize, and the energy output depends the layout and also wave direction, and also is the optimization about power taking off, and also the design of the structure. So that is the figure, and with can is show. Probably, I don't know whether you can, sorry, I did something wrong. So certainly, if everything about 0 means we have the enhanced is power taking off and from this array of the devices, certainly there are a lot more work we are working, and particularly that probably that will be a field trial and to be able happening in China. So that is further and collaboration and with China as well. So I think that is probably is the main topic, and then the main message I want to deliver is we are a coastal country. Certainly, we have the challenges, from climate change, but we also have the opportunity, for getting is more greener and the energy. But we need to work together. Certainly, Southwest and Wales and Scotland, we need to all work together. And thank you very much.